Welcome back, viewers. Today's video is the solution set for the voltage divider challenge set earlier this week. Speaking of which, if you haven't seen this yet, please use the following link, which I will also share at the bottom of this video in the comments section, to have a go at the actual task originally. So onwards with the solution. Here was our circuit for a voltage divider. Pretty simple. It's got a supply voltage, it's got a resistance 1, resistance 2, over which the current travels, and the voltage divides, hence the term voltage divider. And V out is the output voltage we're measuring over V2. And here's our equation. V out equals Vs, supply voltage, times the ratio of R2 compared to R1 plus R2. Can rearrange that slightly and move the Vs from the right hand side of the equation to the left hand side of the equation. And the benefit of that is now that I've got all voltages on the left hand side of my equation and all resistances on the right. And we're now looking at a ratio approach. So you can see here the V out, 2 volts, over the supply voltage 12 is equal to R2 over R1 plus R2. Now, R1 plus R2 can be represented by RT, the total resistance. So now we have a very, very simple expression. It tells me that the fraction of the total supply voltage that's found over R2 is equal to the fraction of R2 compared to the total resistance. So let's try this mathematically. So I sub in the values. V out is 2, Vs is 12. That tells me is the ratio of 1 to 6 in terms of R2 to RT. So in total, there's 6 units of resistance, if you like. Of that, 1 comes from R2, which means the remaining 5 must come from R1. So for this voltage divider to work, the ratio of R2 to R1 must be 1 to 5. I could choose, for example, to arrange resistance 2 as a 10 ohm resistor and resistance 1 as a 50 ohm resistor, and that will give me a 1 to 5 ratio and generate the output voltage of 2 volts. Let's now check this on the PhET simulator. We have a battery here of 12 volts. R1 is 50 ohms, R2 is 10 ohms. The voltage across R2 is 2 volts. Challenge B. Repeating the same process, this time we want an output voltage of 3 volts. As we just said, the ratio of the volts is equal to the ratio of the resistances. So this is 3 volts out and 12 volts in. Okay, it's a 3 to 12 ratio, or a 1 to 4, which tells me effectively, in terms of resistance, I can consider there to be 4 units in total, one of which comes from R2, which means the remaining 3 must come from R1. Collectively, there were 4 units of resistance. One of those 4 is R2. The remaining 3 must be associated with R1. So our ratio of R2 to R1 is a 1 to 3 ratio, which means I could choose resistance 2 to be 10 ohms, and resistance 1 would have to be 3 times greater, 30 ohms. Let's watch this on the PhET simulator. We have a battery, 12 volts, R1 is 30 ohms, R2 is 10 ohms, gives us an output voltage of 3 volts. Challenge C, output of 4 volts from a supply voltage of 12. The same ratios. 4 over 12 is the same as 1 over 3, which means this voltage ratio of 1 to 3 will be same as the resistance ratio 1 to 3. So the total resistance has got 3 units, of which 1 is associated with R2. We have a 1 here in green, 1 to 3 ratio, which means the remaining 2 units must be associated with resistor 1. So to get an output of 4 volts from an input or a supply voltage of 12 volts, my ratio of resistors, R2 to R1, is a 1 to 2 ratio, which means I could choose R2 to be 10 ohms and R1 to be 20 ohms. Let's now check this with the PhET simulator. A 12 volt battery, R1 is 20 ohms, R2 is 10 ohms, and the voltage across V out is 4 volts. Challenge D, an output of 8 volts. Let's go through the same processes again. There's our equation, a ratio expression in terms of volts and resistance. It's an 8 to 12 ratio. Divide both the numerator and denominator by 4 and we get a 2 to 3 ratio. That means in total, the resistance can be considered to have 3 units, 2 of which are associated to R2 and the remaining 1 must be R1. So in order to get an 8 volt output from a 12 volt supply, I must have R2 to R1 as a ratio of 2 to 1. So again, I could choose R2 to be 20 ohms and R1 to be 10. That's a 2 to 1 ratio. Let's see how this works on the PhET simulator. Voltage of 12 volts, R1 of 10 ohms, R2 of 20 ohms. And the Vout being measured across this circuit is 8 volts. Challenge E, I'm looking for an output of 9 volts from a supply voltage of 12. The same ratios again. 9 over 12, both the numerator and denominator can be divided by 3. Gives me a ratio of 3 to 4. The voltage ratio of 3 to 4 is the same as the resistance ratio of 3 to 4. It means, in total, there's 4 units or 4 parts of the total resistance, of which 3 are associated with R2, leaving 1 to be associated with R1. So this is a 3 to 1 ratio, which means I could choose R2 to be 30 ohms and R1 to be 10 ohms as a possible combination. Let's see how this works on the PhET simulator. Voltage of 12 volts, R1 of 10 ohms, R2 of 30 ohms, and the Vout is 9 volts. Our final example, challenge F. We have an output voltage of 10 volts given a supply voltage of 12 volts. Our ratio, as we've discussed for the previous examples. The output ratio for the volts is 10 to 12, which dividing the numerator and denominator by 2 gives me a 5 to 6 ratio. So the 5 to 6 ratio of voltage will be the same as the 5 to 6 ratio for the resistance, which means we can consider the bottom, our denominator, the total resistance as having 6 units of resistance, of which 5 come from R2 and the remaining 1 from R1. So the ratio of R2 to R1 is a 5 to 1 ratio. So I could choose R2 to be 50 ohms and R1 to be 10 ohms. Let's see how this works with a PhET simulator. A battery, or a VS, of 12 volts. R1 is 10 ohms, R2 is 50 ohms. And the Vout across this circuit is 10 volts. Thank you so much for watching this video. I hope it's enabled you to visualize the ratios that exist between voltages within a voltage divider and resistances within a voltage divider. If you've learned something from this video, please like, share, comment, and subscribe. And as always, thanks for watching.